Right, guys, welcome back. So, in this episode, we are going to learn about basic operations on units, how to convert the units of quantities from one to the other. Sometimes you may be given quantities whose units are in the US format and you may be required to convert them to SI units. So, we'll check on that today. We will be building on the principle of dimensional homogeneity. So, if you don't know what that is, do well to check our previous video on dimensions, and the link is also in the description below. We are going to take a few questions. These questions are taken from Hibbeler. In this question, we are told that wood has a density of 4.0 slug per cubic feet. What is its density expressed in SI units? We are given 4.7 slug. So I write it in this format. It makes it easier to visualize. So the per means the cubic feet is sort of a denominator. We just need to know the equivalent of one slug in SI units, and also the equivalent of 1 feet in SI units. And if you can just do a little googling, know that one slug is actually equal to 14.59 kilogram. That's the SI unit. And 1 feet is equal to 0.3048 meters. From here, we see that one slug is equal to 14.59 kilogram. So we can actually replace one slug here with 14.59 kilogram. That's the point. This slug is equivalent to 14.59. In the quantity given, we just replace 4.7 times, and the slug is 14.59 kilogram. So it's multiplying. The value here actually sort of multiplies the units, just to see it that way. So we are multiplying one slug is the equivalent of 14.59 kilogram. So we have cubic feet. Now this cube is affecting this whole unit. Okay, so this unit is cubed. So in your replacement, in your substitution, you're actually going to insert the cube of 0.3048 meters. So it's 0.3048. Now, if we write meters all cubed, you know that this is 0.3048 cubed times meter cubed. So we can just bring the meter outside and cube it, make it cubed. So we evaluate this and we have 68.573 kilogram on 0.0283 meter cube. So we are going to simplify just the numbers and leave out the units. So this is actually going to be 68.573 divided by 0.0283, and that's going to give us 2423.07. And then there's the unit kilogram per meter cube, or kilogram per cubic meter. Now we have to rewrite this in a more standard form, because we see this is 2423. We can actually simplify by moving the decimal place 1, 2, 3 places forward. By moving it 3 places forward, then we have times 10 raised to the power 3. So we have 2.423 times 10 to the power 3 kilogram per meter cube. And we would like to leave our answer in three significant figures. So 2.42 times 10 to the power 3 kilogram per meter cube. Now to the next question. So we are to represent each of the following combinations of units in the correct SI form. Okay, so we have kilonewton per microsecond. Now, correct SI form requires that we do not have a prefix in the denominator. So as you realize, we have the prefix micro, which stands for 10 to the power negative 6 in the denominator, which is inappropriate. So we'll have to move that into the numerator. So for A, kilonewton per microsecond, we know that micro has a value of 10 to the power negative 6. So kilonewton per 10 to the power negative 6 seconds. Now this 10 to the power negative 6, we are just moving it into the numerator. So it becomes 10 to the power positive 6 in the numerator. So we have kilonewton times 10 to the power positive 6 per second. And we are going to combine our kilo with our 10 to the power 6. Now our kilo has a value of 10 to the power 3. And we are multiplying this by 10 to the power 6. So in essence, we have 10 to the power 3 plus 6, which gives us 10 to the power 9. And our 10 to the power 9 is also a prefix, giga. So we have our 10 to the power 9 multiplying our Newton per second. So finally, we have giga Newton per second as our final answer. Alright, so for the B, we're given megagrams per millinewton. Okay, so there's two things we need to do about this. First is we have a prefix in the denominator. We need to move that into our numerator. And then secondly, we have megagrams. The SI unit for mass is kilograms, not megagrams. So it's not a matter of prefix. We actually would like our grams to have a prefix of kilo because the SI unit is kilograms. So we'll have to modify this or break this up. So we have kilos. So first is going to be the movement of our milli into the numerator. So we have megagrams per Newton. Now our milli originally was here. We move it up. And mind you, our milli has a unit of 10 to the power negative 3. When we move it up, it becomes 10 to the power positive 3. So we have times 10 to the power positive 3. And then secondly, we have mega multiplying 10 to the power positive 3. We actually want kilo. So this is what we're going to do. Okay, we can just simply convert our 10 to the power 3 into kilo. So we just have to deal with the mega. We can't have two prefixes attached to one unit. So we'll re-express this as 10 to the power 6. So our mega becomes 10 to the power 6 and our 10 to the power 3 becomes kilo. So we simply have 10 to the power 6. Our 10 to the power 3 has become kilogram per Newton. And finally, for C, we're given meganewton per kilogram millisecond or per kilogram per millisecond. Now, mind you, the whole of kilogram millisecond is in the denominator. Okay, so if we're writing this in linearly, it would be meganewton per kilogram per millisecond, like this. So the problem with this is we have milli in the denominator, which is inappropriate. The appropriate form is to have no prefix in the denominator. So we are just going to move the milli from the denominator into the numerator. So simply as we've done earlier, our milli is 10 to the power negative 3. When we move it into the numerator, it becomes 10 to the power positive 3. So we're just going to do that straight up. So our meganewton becomes meganewton times 10 to the power 3 per, and then we have just kilogram second now. We are not going to move kilo as a prefix because kilogram is the SI unit for mass. So our mega multiplying our 10 to the power 3, we're going to combine them. Our mega is 10 to the power 6, and then multiplying 10 to the power 3, so we actually have 10 to the power 6 plus 3, which is 10 to the power 9, which is giga. So our mega times 10 to the power 3 becomes giga, and our final answer is giga Newton per, we still have this, per kilogram second. So moving on, we are to represent each of the following combinations of units in the correct SI form using an appropriate prefix. Okay, meters per millisecond. I hope you get a difference between these two M's. M standing alone is a meter, obviously. and then attached to another unit, it's milli. So we have meters per millisecond. Inappropriate for us to have a prefix in the denominator, so we move this into the numerator. Our 10 milli is 10 to the negative 3, moves into the numerator, it becomes 10 to the positive 3, which is kilo. So we just have kilometers per second. B, we have micro multiplying kilometer. Inappropriate because we have two prefixes attached to one unit. We according to the SI standard, we need to have only one prefix attached to a unit. So we are going to merge micro and kilo. Micro is 10 to the power negative 6. Kilo is 10 to the power 3. Negative 6 plus 3, we get 10 to the negative 3 meters, which is millimeters. Kilosecond per milligram. Okay, so the inappropriate thing here is that we have milligram. The SI unit is kilogram. So we need to find a way to turn this milligram into kilogram. Now, there are a number of ways you can do it, and this is how we're going to approach it. So we have kilosecond in the numerator, dividing milligram. Let me just expand. So we have our kilosecond. Our milli is 10 to the negative 3, then our gram. Now, how can we know kilo is 10 to the power positive 3. How can we turn our negative 3 into positive 3? If we added 6, then 6 minus 3 will make positive 3. So we're just going to multiply the denominator by 10 to the power 6. So 6 minus 3 gives us 3. But this changes the value, so we need to do the same to the numerator. So multiplying numerator and denominator by 10 to the power 6 doesn't change the value of the overall fraction, because 10 to the 6 over 10 to the 6 is 1. So this is just like multiplying by 1. We've not changed the value of our overall fraction, but we want to make use of our 6, our new entrant in the denominator. So 6 minus 3, this gives us kilosecond times 6, dividing 6 minus 3 is 10 to the power 3, and our 10 to the power 3 is kilogram. Now we have our kilogram here, so dividing kilogram. So here we just need to further simplify our numerator. So we have kilosecond multiplying 10 to the 6. Our kilo is 10 to the 3 seconds times 10 to the 6 of a kilogram. 10 3 times 10 6, that gives us 10 to the power 9 seconds, and that gives us gigaseconds per kilogram. Next and final set, we have to evaluate 354 milligram multiplying 45 kilometers and then being divided by 0.0356 kilonewtons. Okay, so we write in full 354 milligram multiplying 45 kilometers, then all divided by 0.0356 kilonewton. So first and foremost, we will have to leave our milligram as kilogram, because that's the SI unit. And then we'll have to evaluate our multiplication going on between the numbers here. So 354 multiplying 45 and then dividing 0.0356. So we are going to do that independent of the units. We're going to pretend the units are not there. So we'll just do 354 times 45 divided by 0.0356. So just that, 354 times 45 dividing 0.0356. And then we still have our units here. Milligram, kilometers, and then kilonewton. So our numbers, when we calculate, we're going to get 447,471.91. This is from this, and then we still have our units: milligram, kilometers, and then kilonewton. So first, we know we are definitely going to have to present this in a better format. So we will move our decimal places an appropriate number of times. So we count 1, 2, 3, and then 1, 2, 3. Remember, it needs to be 3 or 6 or 9. So 1, 2, 3, and then 1, 2, 3. I think we're going to use 0.447. So we moved it 6 times. So our number now is 0.447. And because we moved our decimal place 6 times, we have 10 to the power 6. And then we still have our milligram, our kilometers, and then our kilonewton. Now to simplify this further, we know that we will need to leave our milligram as kilogram. We have a kilo here, so I'm just going to perform a little switch. Just move this kilo before the gram and move this milli here. It doesn't change the value. So our milli is going to join our meters here, and then our kilo is going to join our gram. It's just to make our work simpler with the kilogram. So we now have kilogram and millimeters. We just moved our milli to join the meter, and then we moved our kilo to join the gram. And then we still have our kilonewtons here. And then we have 10 to the power 6. We have 10 to the power 6 milli and our kilo in the denominator. So just to isolate our kilogram, okay, so we have our 10 to the 6 and our millimeters and our kilonewton in the denominator. Our milli is actually 10 to the power negative 3. So let me write it that way. 10 to the power negative 3. And 10, 6 multiplying 10 to the negative 3, we have 10 to the 3 because 6 minus 3 is 3. So we actually can rewrite this as our kilogram still there. 10 to the power 3 meters dividing kilonewton. And now remember, our kilo is actually 10 to the power 3, or our 10 to the power 3 is actually kilo. So this can cancel out with this. And then finally we have just kilogram multiplying meters and then per newton. Then we join this with our 0.447. So this becomes our final answer, 0.447 kilogram meter per newton.